So I'd like to introduce Brian Sullivan. Brian Sullivan is a senior security researcher with Adobe Systems, where he focuses on cloud security. And prior to Adobe, Brian was with Microsoft, where he worked on the SDLC, development manager for HP, and help with HP's vulnerability scanning and web inspect and dev inspect tools. So without further ado, please welcome Brian Sullivan.
Thanks. So welcome everyone, thanks for coming. This is server-side JavaScript injection, attacking and defending NoSQL and Node. So let me just get a brief kind of temperature taking to see where we are in terms of like awareness and adoption kind of thing. So who here is actively using NoSQL right now? How many people how many people are using Node? Wow, okay. How many people have never even heard of NoSQL or Node before? Okay. You guys are all cool. I will be talking about this in detail. So if you've just come in because you couldn't get into Dan's talk or something, you're all good. So I know I have the coveted after lunch spot. So to make sure that nobody falls asleep after lunch, we're going to start things off with a little pop quiz. So this is kind of a spot the bug exercise. If you think you know what the bug is, please just raise your hand and shout it out. Oh, and by the way, if you have like any questions at any time, I'm going to try to leave a little bit of time at the end for questions. But I don't want you to save something up if it's bothering you the whole time and then you'd be confused the whole time. So if you have a question at any time, just raise your hand, ask it. I prefer to answer it like in line anyway. All right, so let's get to the bug. All right, so here it is, a little bit of HTML, a little bit of JavaScript. Actually, it might be easier if we instead of look at the source code first, let's look at the actual thing first. So here it is, Math Wizard. What could possibly go wrong here? So enter an expression, any expression. All right, well, 2 plus 2. Calculate 4. Hey, look at that. What's another mathematic expression? How about 3 times 7? Calculate 21. Hey, looks good. So I think somebody is already cheating. All right. So what here catches your eye? What could possibly go wrong with this incredibly simple bit of code? Eval data, of course. And what does this mean? What kind of vulnerability is this? XSS, cross-site scripting. Exactly right. So let's go back and do it. So if we say here, instead of 3 times 7, if we say alert, you are owned. Boom, you are owned. Okay. So here's just for a little bit of bonus points here. What kind of cross-site scripting is this? There's 3 kinds of cross-site scripting. Which one is this? Reflected? No, it's not reflected. DOM-based, exactly. It's DOM-based XSS. We're not even making a round trip to the server here. This is all done directly in client-side JavaScript. Off of a static HTML file, by the way. And that's kind of profound when you think about it, isn't it? We have a static file. It's not even making a round trip to the server. And you have a cross-site scripting vuln off it. It's probably a subject for a whole other talk. But I mean, to me, that's kind of astounding that you can have something that's just static HTML that actually gets you owned in such a way. All right, but let's continue. So cross-site scripting, as we all know, you guys picked it out immediately. Fantastic, you're awesome. And we all know it's bad, right? But I mean, I think cross-site scripting is probably like the worst named vulnerability of all time, right? It is so not indicative of what the problem really is. Like here's my favorite story about this. I was at a con once, and I was talking to someone about some secure development practices, about the OWASP top 10, and pretty knowledgeable guys, right? So I said, hey, what are you doing to defend your apps against SQL injection? They're like, oh, well, we parameterize all our queries. We're doing stored procedures. We're locking down permissions on the database. I'm like, all right, you guys got your stuff together pretty good. I'm really impressed. So tell me what you're doing about cross-site scripting defense. You guys are like, we don't need to worry about that at all. I'm like, really? Why don't you need to worry about cross-site scripting? He's like, we don't even use cross-site scripting. I'm like, oh. OK. So cross-site scripting isn't something you use. It's something that gets used against you. So we had a little educational moment as to what cross-site scripting really was. Now, if it had been up to me, I would have never called it cross-site scripting. I would have called it JavaScript injection or HTML injection, which is really much more indicative of what the problem really is. But as we see, it's much more than just what happens on the client in terms of JavaScript injection. So your client-side JavaScript injection is what gets you cross-site scripting. And this is number 2 on the OWASP top 10. This is number 4 on the new CWE SANS top 25. It used to be number 1 on the CWE SANS top 25. Think of all the incredibly evil stuff you can do with client-side JavaScript injection. You can steal cookies. That's the canonical example, right? Steal somebody's auth cookie, send it back to yourself, and now you take over their session. You have the SAMI webworm type thing. You can install keystroke loggers. You can do all kinds of these incredibly, incredibly evil, malicious things. And that's on the client. When you see the same thing on the server, it's 10 times worse, at least 10 times worse. So you may say, OK, like, what do you mean on the server? Like, what is there anybody even doing like server-side JavaScript execution? Isn't that kind of like a fringe thing? No, it's not. It's actually surprisingly widespread. There are a lot of people doing server-side JavaScript execution. Actually, people have been doing it for years and years, all the way back to the 90s. But it's growing exponentially, I think, in part for 2 big reasons. And one is this fallout from the browser wars. So now you've got all these browser manufacturers competing to see who can get the most market share. You've got IE and Chrome and Safari and Firefox and Opera and all these. And they all fight on what basis? Like, what's the number one thing that, yeah, I would say, like, I hope nobody here should say security. We all know better than that, right? No, it's speed, exactly. It's perf. It's who can make the fastest JavaScript engine. And that's good for us as consumers, right? I like my browser to execute quickly. And it's kind of a side benefit of that. A lot of these engines are open source. Like, you can go use V8 if you want. You can go use JavaScript core if you want. And people are doing that. People are they have these incredibly fast, incredibly performant script execution engines. And they're taking them and they're building new technologies with them that run on the server. So that's factor number 1. Factor number 2 is that you have a large number of developers who are already really well versed in this particular technology. Now, think about your normal web development shop. Basically, you've got 2 groups of guys. You have the front-end guys who do like the web-facing stuff. And these guys know how to do HTML. They know how to do JavaScript. And they're kind of relegated to like the front-end code. And not to trivialize it, but that's kind of the stigma that goes along with it. And then you've got the hardcore back-end guys. These are your Java guys, or your C++ guys, or your PHP guys. So you've got two completely different sets of people with 2 completely different skill sets. Well, that's not really optimal, right? Wouldn't it be better if everybody just had a common language? If you had a common pool of programmers, and you could say, all right, well, this sprint, you guys are going to work on the front end, or this sprint, you're using the same language. If you go to 100% JavaScript in both the front and the back, you share these groups of people between. So again, I think this is another big reason why we're seeing this. You've just got so many people who are really well versed in it. Why not use them for both the front and the back, as long as the technology is there to be able to do it? Now, all that I said, Chris Cowell put infinitely more succinctly than I did when he said, despite its deplorable shortcomings, JavaScript is cool and people like it. That's exactly it. You can't really get anything more succinct than that. So what kind of things are people building with it? Well, they're building databases. So we got just two right here. So Couch and Mongo, we're going to be exploring these in depth over the course of the next hour or so. And so these are either, these types of databases are either written in the JavaScript execution engines that I talked about, or maybe they just use JavaScript extensively for filtering or for MapReduce. And again, we'll talk about these extensively over the course of the session. What else are they building with them besides database? I mean, and to me, if you stop and think about it, 10 years ago, if someone said, hey, we're going to build an entire database engine out of JavaScript, you're like, haha, well, I hope you've got some time. But no, now that the performance is there, you can do it. What else can you do? Well, you can make web servers. And this is what Node really is. And so if you're unfamiliar with Node, it's spelled Node.JS, but usually just pronounce it Node. The .js is there just to distinguish it from the other 100,000 nodes, so people know exactly what you're talking about. But what it is you can actually make web servers just based out of JavaScript. So we've got this is a whole web server right here. So it starts, you pull in an HTTP module. This is all JavaScript. You create a server, and it just responds to any request that comes in. It writes back a response code of 200, a content type of text plain, and then hello world. And it listens on port 1337 and then logs. So you've got 5 lines of code here, really. 6 if you include the log. And I know that's probably a pretty wordy way to do hello world, but you get the idea. You can do really complicated things in a really small amount of code, and it's really, really fast. The performance of this is really good. So all right, let's pop over to Pop Quiz Part 2. Again, keeping everybody on their toes. I think my IP changed on my Node server. Give me 1 second here, people. Yes, it did. All right. Well, this demo is going to work less than previously indicated, but you'll get the idea. All right, so we've got here the intent, which is now not going to work because of the AJAX call, is you enter a ticker symbol, Microsoft or Google, whatever, and it goes and fetches you the current value of that stock price. With a little bit of, it used JSON to send across the wire. So it would create this JSON on the client, send it back over the wire using XML HTTP request, process that on the server, and come back. And we'll take a look at the code, and you can see exactly what it did. So here's the HTTP create server that we showed in the last slide. We're gonna again write the 200, write a content type of text HTML. This is all the HTML that we're going to write back to the client to do the AJAX call. If it's a GET request. And if it's a POST request, then that's the JSON coming back in. So I'll give you a hint and say, if there are any bugs in this, that's not what I'm particularly looking for. I want you to find the bug in the POST. Eval data, hey. It's almost like you've seen that before recently. Exactly, eval data. So what we're doing is we have this little bit of JSON coming in, and if you're unfamiliar with JSON, so JSON is JavaScript object notation. It's a way to represent data in a JavaScript object. It's actually made explicitly for this purpose. So you can just say, hey, I want to eval this bit of text, and it automatically becomes a JavaScript object that you can work with. Really, really handy. But again, really, really, really vulnerable. So all this time, I have had my little request builder open here. So I've attached Fiddler, which is actually one of my very, very favorite tools, as a little bit of web proxy, so I can see what's going back and forth across the wire. And not only can I watch what's being sent, I can change what's being sent. I can even just craft my own particular requests to send. I don't need to go through a browser. This is one of the, I don't need to tell anybody here this, but this is one of the primary rules of security is that hackers don't use browsers. Hackers use other tools to attack, and that's exactly what I'm going to do. So given that this app is going to eval the data that I send back over the HTTP request, I'm gonna try something different here. So I'm going to try response.end owned as a little proof of concept. And now this is already, you see how fast that was, that came back. And this is actually what came back from the server, was owned. So I know that the response end command basically says, hey, this response object that I'm building, all right, I'm done with that now, and here's what I want you to spit out. So I did it, and I did it, and this is my proof of concept. Now I know that whatever script that I send to this node server is going to execute on the server side tier. Well, all right. Now that I've got execution, what do you think would be some cool things to do? Well, first of all, you would say that anytime you have server-side code or anytime you have server-side JavaScript injection, this automatically implies client-side JavaScript execution, right? I can easily go here and say something like response.end script alert 1, 2, 3, 4 script. And so if I were to actually like send this, that could, not the alert, but I could steal cookies. So your server-side script injection implies XSS. We can probably do a lot better than that. How about this? How about while 1? Execute. You'll see the response from this hasn't come back, and it's not likely to actually come back anytime real soon. Because now this is pegged at 99%, and it's going to stay there for a while. Now, before you say, OK, well, that's just a silly little nuisance attack. That doesn't mean anything. I think this is incredibly underestimated. I think most people focus so much on, so you think of the CIA, confidentiality, integrity, availability. So many people focus so much on that confidentiality and integrity and like, availability, DOS, big deal. We crash in response. No, it's a huge deal. Think about what would get any of your organizations into the news. Like, is not to diminish its importance by any means, but is like a reflected cross-site scripting going to get you on the front page of the New York Times? No. Nobody even understands it. Nobody's going to care about that kind of thing. Not that it's not important to us. It all needs to get fixed. I'm not saying that. But what gets you on the front page of the New York Times? Well, data loss. OK, like company X, million users' credit card data stolen. Yeah, that'll do it. What else gets you on the front page? Denial of service. If you're a respectable sized company and your service goes down, especially think about in a web environment, in a cloud environment, if people can't get to you, you're done. It's over. That does get you. I mean, if Anonymous and LulzSec has taught us anything, it's that. So this is, in my opinion, an incredibly underrated vuln, especially when you see how easy that was. It's still pegged. I have to kill it right now. I didn't need a botnet for that. That wasn't a big DDoS attack. That wasn't anything that I needed, my 10,000 followers to all hit it at the same time. It was while 1. That's what 7 characters of HTTP took down a site completely until I'm going to go manually restart it right now. So that's an incredibly asymmetric, incredibly effective attack. But that's by no means the worst thing that we're gonna do to this right now. And by the way, I think it's incredibly ironic that people go to Node for high scalability and high perf, and then you can end up killing it with one 6-byte request. All right, enough with the small time stuff. Let's do some real damage. So Node supports this initiative called CommonJS. So CommonJS, that was the quote I had earlier from Chris Cowell. He's kind of the father of CommonJS. And what it is this initiative to kind of create a standard library framework for JavaScript. The way that every other modern programming language has this, we kind of take for granted, is to some extent missing in JavaScript, and that's what this initiative is for. So we want to create this common API library framework of JavaScript APIs, which is great. I totally endorse it. I think this is a fantastic idea. And you can see we already showed it here in this where it pulls in this require HTTP. That's taking advantage of this. It's saying, hey, I want you to pull in the HTTP module so I can do the HTTP processing of this request. OK, cool. Well, let's take a look at everything that you can do in this. OK, well here. OK, sorry. One more thing before we get into that. So if we wanted to exploit that just on its own, OK, well I can go back into Fiddler. And I'm going to send this. I'm going to actually have it make its own HTTP requests. So I can actually use that server as a proxy server to attack other sites on the internet. And maybe that's a little bit harder to trace back to me. That's kind of cool. You use somebody else's bandwidth to make your attacks. I like that. What else may be good for? It may be good if you've got inside knowledge of the intranet of that site, right? Like maybe they've got a database server, maybe they've got a NoSQL database server sitting on that same server inside their firewall, and you can't get to that directly. But hey, if I can execute arbitrary JavaScript on your Node server, maybe your Node server has access to port 8124, whatever other things you're running on, and I will use it to tunnel inside your firewall and attack you that way. But above and beyond that, you can do all this other stuff. This is the complete API documentation for Node. This is everything that Node can do. There's a lot of stuff there. And this is a full-fledged product here. Anything jump out at you? Anything look really, really interesting? Like you might want to explore this in some more depth? OS? OK. Yeah, actually, OS is not as interesting as it sounds. But we're going to get into something like that. Which one? Which? C and C++, yeah, that's not a bad one either. But we don't even need to get into that. I know why you want to get into that, but you're not even going to need to. No, we're going to get two. The two that caught my eye, the first one was file system. OK, what can we do with file system? Well, let's take a look. One thing you can do is you can read arbitrary files and directories off of the server. So what I'm going to do is I'm going to say, and by the way, I didn't mention the functionality where it pulls in. Let me go back to the slides for a second. Where it pulls in this HTTP module. The code that I have for this Node module does not actually use the file system module. You have to require FS in order to be able to access the file system. And I haven't done that. Now, does that mean that I can't access the file system? No. It just means I have to append that to my exploit string. So that's what I'm going to do. So coming in here, I'm going to say var fs. It's probably too small to read. I'll call it out for people in the back so you can kind of hear what I'm doing. So I'm going to pull it in. I'm going to say var fs equals require fs. And now I have complete access to the file system functionality of Node in order to execute my attack. So now I'm going to say response.end fs.read_dir_sync. So this is a synchronous read directory of C:. ToString. If I got that right, looks like I did. You see here just a comma-separated string of everything that's on C: on the Node server. And it's worth noting that C: is outside of the web root of the Node server. The Node server is actually running in a directory. It's like C node.js bin or whatever. it just totally went outside that. It went all the way straight up to C: of the machine. So I can get a directory listing. If I can get a directory listing of C:, that's basically says I can get directory. I can map the entire folder structure of the entire machine. And better than that, I can read the contents of the file too. So let me go back to Request Builder, and I'm going to say response.end read file sync, and there was one there. Oops, hang on. Yeah, we'll do secret.txt. It's like it was put there just for the presentation. So we're going to read file sync C: secret.txt and execute. Yeah, thank you. It just crashed too. But that's OK. I'll just restart it. Hey, that's a pretty good DOS in and of itself, isn't it? All right, try again. OK. And we see that the secret is, in fact, swordfish. How about that? Just like the movie. All right, so now let's take a look at what we got. We can read the complete directory structure of the machine and list out all the contents of the files. This is a pretty good hack already, but we're not done yet. What else can we do? Well, we can write to the file. So how about we write file sync secret.txt, and we're going to change the secret to tuna. Oops, actually, you know what? I will just pull this out into a separate line, and then we can make sure that it works. One more. OK. Thank you. Thank you. All right. All right, so we'll try this. You guys are awesome. Thank you. All right, now we're good to go? Now we're good to go. OK, so it's come back. OK, tuna. And if we look here on the server, I will pull up secret.txt. And you can see, in fact, we have changed the secret to tuna. All right, so this is already really, really good. Now we can read the entire machine. We can read the entire contents of the thing, and we can write to the machine. So we've pretty much owned them at this point. But you know, there's some more stuff that I think is really cool we can look at here. Oops, keep going. The other one of these I thought was really the most interesting was child processes. So yeah, let's take a look at exactly what you can do with child processes. So this time, I'm going to do, actually, I may just use my little cheat sheet here. Sorry. What's the tradition here for launching these kind of attacks? It's calc. So I'm going to require child process, call the spawn method, and I'm going to have it spawn C Windows System32 calc.exe. And then I'm just going to response end with success. So it's response ended with success. Great. Let me go back to the server. And hey, look at that. Calc has popped up right there. If that's not good enough for you, let's combine these last two. Let's say now we have the ability not just to write files to the server, but we can execute arbitrary binaries on the server. Hey, let's combine those two. So back to the exploits, and I was never, ever, ever going to remember this one. Maybe like one of those guys who can recite pi to like 5,000 spaces could do this, but not me. So this is a base 64 encoded binary. You know, still pretty small overall. I will send this up to the server. It's going to be called foo.exe, and it looks like that worked OK. I got my success response, and then I'm going to launch it. Yeah, I probably could have done that all in one request. I just wanted to kind of play it out between the two. And that one looked good too. So I'll come back over, And here we see it was just Windows Media Player. But so now we've owned the machine. We're done. I mean, anything more we do to it at this point is totally limited by our imagination. Like, we don't need to get into the OS calls. We don't need to get into the C and C++ stuff. I can upload an arbitrary executable to your machine and run it. So that's it. It's over. I won. And that's why I thought those two in combination were really the only two you need. All right. So that's, I mean, if anybody has any questions on Node, I mean, there's really nothing much more I can do to it. Anything else at this point would just be silly and showing off. And we'll talk about some ways to do this. Because like the hole that led us in to do all this was that little call to eval. That little call that on the client side, yeah, it was a DOM-based XSS that may have let us steal somebody's cookie. That exact same eval call just let us execute an arbitrary executable on the server. So that's kind of a big deal. But we'll actually see some other ways besides that eval that you can get your malware up there. But yeah, like let's say what if we were to put a CVSS to this? If we were to score this via CVSS, here's the formula. So the related exploit range, well, I did it remotely. OK, so remote. The attack complexity is ridiculously low. I didn't need auth to do this. I have a complete impact to confidentiality. I mean, I can read the entire machine. I have a complete impact to integrity. I can write anything on the machine. And I have a complete impact to availability. So I just killed the whole thing with a while one. And if I really wanted to do more than that, I could start deleting files or whatever. So if you score this via CVSS, it comes out to 10, which is about as bad as it gets. And above and beyond that, like the way that I exploited this is much more like a SQL injection exploit than a cross-site scripting exploit. Didn't need any social engineering, didn't need to trick anybody into clicking links or anything like that. It was just me sitting back in my office and plugging away with it as much as I want all on my own. So very, very easy way to do the exploit too. I think this is really, really terrifying. But let's move on to NoSQL and take a look at some more exploit vectors. So NoSQL we kind of mentioned earlier. You have a bunch of different databases here. Even if you're those of you who may not be familiar with NoSQL, you're probably familiar with the names, right? Hadoop has HBase. There's Cassandra, React, MongoDB, CouchDB, Neo4j. There's tons of them. And it's probably easier to explain what NoSQL is not than what NoSQL is. What it's not is it's not a competing standard to SQL. There's not like a common NoSQL syntax. Like everybody knows SQL is select star from table where x equals y or whatever. There's none of that in NoSQL. There's no common syntax across all the different databases. Basically, what NoSQL is just a way to refer to certain types of non-relational databases. So these could be like key value stores or table-oriented stores, things like that. Generally, you have, and again, they all vary wildly. It's difficult to make like sweeping generalizations about what NoSQL does, but generally, there's no enforced common schema. So in SQL, you have tables where you have columns, and every row in that table has exactly the same columns and exactly the same types. Not necessarily true in NoSQL. You could have a collection of a million different documents, and each one has a structure completely unlike every other document in there. They're generally not ACID. So we take ACID in relational databases kind of for granted if you've been doing it. So atomicity, consistency, isolation, and durability. That all gets thrown out with NoSQL. There's generally not ACID. What there is instead of ACID, they have base, which is kind of clever. So base is basically available, soft state, and eventually consistent. Now the eventual consistency thing is, actually that's a whole other talk that we were not going to get into today. But yeah, to me, eventual consistency is a fancy way of saying race condition. But again, We're not going to get into that too much. What these databases are, they're really designed for working with really large amounts of data and really high scalability. Like, the problem that they try to solve is that when you're working with petabytes and exabytes of data and trying to do like all this massive amount of processing, it's hard to do that with straight SQL because, and there's only so far up you can build a certain machine, and it gets really, really expensive. And when you start to try to scale horizontally instead of scaling vertically, well, again, that becomes tough too in straight relational SQL because you've got joins between your tables, and now it's tough to do like the horizontal scaling unless you're willing to spend millions of dollars, which a lot of people don't even have. So yeah, it's tough, and NoSQL is designed to get around these issues by having very, very high scalability, very, very high availability. All right, so this is the third and last, I promise, it's the last pop quiz. And I've given you a little bit of hint as to what the answer is already with little Bobby tables. All right, actually, here's the code. This is code. This is PHP code for a MongoDB client. I'll show you. Actually, I'll show you what it looks like in real life first. So let me switch back. All right, so I've got a little administration portal, right? So what does everybody try to break into an admin, or to break into a portal is admin. And we see that, no, it didn't work. OK, so we can't just brute in via admin. All right, what here jumps out at you as maybe vulnerable? It's not eval this time. Did the Bobby tables not give it away? I'm sure everybody has read that cartoon. OK, so it's an injection attack. It was kind of a trick. It's not a SQL injection. It's a NoSQL injection attack, but it's not immediately obvious here. So we've got we're pulling the user ID and a password from the query string, and then we're looking in our collection. So what we do is we say, OK, we have a new instance of Mongo. I want to go to the logins database and the logins collection within the logins database. I'm going to look for a document within that collection of logins where the user ID is the specified user ID and the password is the specified password. And if we find at least one of those documents, if at least one of those documents matches that query, then we let the person, we just cheat here. Then we let the person in. Otherwise, you're rejected. So this is the Mongo NoSQL equivalent of select star from login where user ID equals X and password equals Y. And the normal way that you exploit that is ticker 1 equals 1. So my username is foo and my password is X or 1 equals 1. And since 1 equals 1 is always true, it pulls back the entire contents of the table and lets you in. This is the exact same thing, sort of. Let's go back to the slides for a minute. In general, NoSQL injection is a fairly rare thing if you do it the right way. So if you go through and you say, hey, I'm going to use the specific drivers for the specific language and the specific database that I'm actually using. So let's say I'm using CouchDB in Java. If you go download the Java driver and use that, you're generally pretty safe against SQL injection because the driver is going to, well, you're as good as the driver provider made you, and that's generally really good. I haven't found any egregious errors in any of the ones that I've looked at. Not to say that it might not change in the future, but I feel pretty comfortable saying if you're using the drivers, you're pretty good. Now, if you're just going out, like most of these NoSQL databases, they work off of like a REST API. So if you're just creating, and JSON over REST, by the way. So if you're just creating ad hoc JSON against like ad hoc REST, yeah, you could be vulnerable to a NoSQL injection. So don't do that. Go use the driver and use your object format to use your object to access the database. But the special case here that you need to know about is MongoDB and PHP, which is a pretty common combination. So MongoDB expects its input in a JSON array format. So if I want to find, so if I've got a music database we're going to show, if I want to find all the albums where the artist is Amy Winehouse, so I would say find artist Amy Winehouse. Sorry, was that too soon? Sorry. And the way you do it in PHP is you make an associative array. So you right here, you use the array method. So you instantiate a new array, and you say the key of this array is artist, and the value is Amy Winehouse. And it creates this associative array that gets passed to the database and executed. Great. This works really, really well. I mean, and this is generally pretty secure against injection attacks. It's kind of like a parameterized query in a way. Very cool. You also use associative arrays for query criteria. So instead of just saying it's hard-coded, like I want to find artist Amy Winehouse, you can use queries. So I want to find all the albums where the album year is greater than or equal to 2011. So everything that was released this year. Cool. Or find me all the albums where the artist is not equal to Lady Gaga. Also cool. So far, so good. But here's the thing. PHP will automatically create associative arrays from query string inputs with square brackets in them. So if I call the page, so page.php, and then if it's expecting param equals foo, if I say param square bracket foo equals bar, PHP is automatically going to make this associative array to associate the key foo with the value bar. And now we're going to take advantage of that. So I've got another Mongo demo here. Change the, and I can search for things. So I'll say I'm going to search for artist Weezer. Whoops, Weezer. Search. Boom. There it is. Got it. Excellent. But I'm going to change that, and I'm going to. Oops. Actually, you know what? I got one demo ahead of myself. I'm going to come back here and exploit this first. So we know that admin doesn't work. So if we know that admin doesn't work, how about I do user ID not equal to admin and password not equal to admin, and that's success. So we already knew that admin would work. So we also knew that not admin was going to work too. And that's all we had to do to just break into this database. This is exactly the equivalent of apostrophe or 1 equals 1, is square bracket NE in the query string, and boom, we got in. Now you may say, hey Brian, this is supposed to be a talk on server-side JavaScript injection, and all this NoSQL injection stuff is kind of cool. It doesn't really have anything to do with server-side JavaScript injection. Yes, it does, because there's one more clause here besides GTE and NE that's of real interest to us, and it's where. So the where clause lets you specify script to filter your results. Remember what I talked about before. There's not generally a common schema. You could have a million documents with totally different format to each of them. So how do you do complex filters on that? You do complex filters with JavaScript. Of course, everything is JavaScript these days, front and back. That's what the whole talk is about. So I'm going to create a JavaScript function, and it's basically, this is going to return true or false. And I can do anything I want within that. And if it gets true, then that document is going to be returned as part of the filter, and if it's false, it's not. So at this point, I can do that same thing again. I can say, I'm going to create a function, and I'm going to return artist equals Weezer, so this will pull back all the Weezer ones. OK, cool. Let's say I want to do something really wild and off the base. So I've got this other function here, and what this says is this is only going to return me the albums where the artist name is a prime number of characters long, which is incredibly silly, but it just goes to show that you can execute arbitrarily. I don't even know how you do that in SQL, by the way. Arbitrarily complex queries in JavaScript against a database. But now we can use this method to inject arbitrary JavaScript to execute as part of our query. So let me go back to the other one that I got a little bit ahead of myself on. All right, so up here, I'm going to search by artist and Weezer. I'm not going to do that. I'm going to search by $where. And now in here, I can do whatever I want. So I'm going to say function and here's my payload. So I could do, I could do the where one thing and shut my machine down again, but I think you've seen that before. Can we do all that other cool stuff? Can we pull in the file system? Can we pull in the child processes? Not in this case. You can't. Just because those libraries don't exist in Mongo yet. If they add them, it might become available. But for right now that's kind of off limits to us, which is good. But as it turns out, we're not going to need it. We're going to be able to do some other pretty nasty stuff. Here's what we'll focus on. First, we're going to say return true. So this is going to, like, I want a listing of all the documents. OK, well, it turns out there's only 3, but that's good enough for our purposes. OK, there's not really anything malicious there, right? You just listed out the contents of that particular collection, and we could have got that anyway. Maybe there'd be some sensitive data in there. Probably not, because we're still locked to that one specific collection. We haven't been able to break out of that yet. So this is not that great of an attack. How about this? What if we say, instead of return true, return false? And that comes back with nothing. Well, how lame is that, Brian? You had it before where you returned everything, and this returns nothing. What was the point of that? Well, what was the point of that? What does that tell me now? Anybody? It tells me what the difference is between a true and a false question to ask the database. Now, I can pass it any arbitrary bit of JavaScript, and if it comes back true, I know what that result looks like. And if it comes back false, I know what that result looks like. And this is the same thing as blind SQL injection, but this is blind NoSQL injection. And because I know the difference between what a true query looks like and what a false query looks like, I'm going to extract out every bit of data from this database. So we'll start off, and we'll say, actually, I got to go back to my cheat sheet. So here's what we're going to say. We're going to say, hey, return db.getCollectionName. So database is a built-in object. .getCollectionName. So this is all the collection. So it's kind of the equivalent of table names. So all the collection names, how many of them are there? Is there just one? No, apparently there's not just one. Well, are there 2 of them? Nope. Are there 3 of them? Yes. There are 3 collections in there. Great. Let's take a look at the first one. So is the length of the first one 1 character long? No. Is it 5 characters long? Yes. All right, what actually is it? Let's say, OK, so the first collection name, the first character, is that equal to an A? No. This could go on for a really, really, really long time. Is it an M? Yes. And eventually what we discover is the first character is an M, the second character is a U, the third character is an S. And we'll eventually extract out the fact that the first collection name is music. And then we'll dive into each individual item within that. We'll say, all right, so the contents of that, what are the contents? We'll do 2 JSON, 1 string. So list out the entire contents of that collection in one big string. I'll check is the first character an A? Is the first character a B? Et cetera, et cetera, et cetera. It'll take you all day, and you're not going to do it by hand. You're going to have some kind of automated tool to do these millions and millions of requests. But hey, guess what? There are already tools like this for blind SQL injection. It's really only a matter of time before someone comes up with one for NoSQL injection. Is going to automate this entire process. And again, just the fact that you can tell the difference between a yes and a no means I'm going to eventually get everything there is to get out of this database. All right, so I have one more issue to talk about in terms of JavaScript injection. It's another NoSQL one. And if there's any questions on NoSQL injection, I'm happy to take them. or save them to the end, or whatever. The other issue I want to talk about are forgery attacks against the APIs. And this is again a pretty big issue with NoSQL in general. Most NoSQL databases kind of actually actively discourage you from using any kind of auth on the database, which is crazy to me. Here's some quotes from the various documentations of the different databases. So Mongo says, hey, one valid way to run Mongo is in a trusted environment with no security and authentication. So trusted basically means you trust the people who use it, which, yeah, that's a little scary. Cassandra says, the default allow authenticator approach is essentially pass-through. Couch says, the admin party is the default. Everyone can do everything by default. And React has absolutely no auth whatsoever. And the ones that are there, I mean, I kind of see, like, they discourage you from using it. Again, what's the point of using this? It's perf and scalability. And hey, security kills perf and scalability. So you understand why, but I mean, that's horrible. And what's there is actually really bad. Some of the ones, a lot of them, like I said, a lot of them don't have anything. Some of the ones that are there are like, we have some basic auth, but they actually store the usernames and passwords in plain text on a flat file on the server, which is not a great solution. The best one I've seen is like, we're going to do unsalted MD5 hashes. Like that's super, super secure. So basically, you're going to have to roll your own auth approach if you want a good solid auth for NoSQL, which is really unfortunate. And I hope the ecosystem kind of catches up to modern standards of auth security. But let me show you exactly why this is gonna bite us in terms of NoSQL. First of all, is just the port scanning. So you're gonna run this database on some port on your server, and if you accidentally forget and leave it open, the attacker already won. All he has to do is go download the client and attach directly to it. And a lot of times there's web interfaces on these. So if you just forget to seal it up, I can just log on and do whatever I want. There's no auth. I'm admin. But let's assume that this is too trivial of an attack to really talk about. Let's assume that's not going to happen. Well, okay, we're attackers. We're bad guys. That's not going to stop us. We are going to, if we can't do something directly ourselves, well then we'll just get someone else who does have permission to do it for us. So what we're going to do is we're going to CSRF around the firewall. So we're an attacker right here. And what we really want to do is I want to call to DB server, and so it's running a NoSQL database on port 1234. I want to call DB server 1234 delete DB to go delete the database and DOS the system. But I can't do that. The firewall stops me. I'm not in the approved list of clients to be able to get right to port 1234. But what I can do is I can spearfish you. You're already inside your corporate intranet. You do have access to DB server 1234. If I can get you to open an email that I send you, or if I can lure you to some malicious page, well then, you being inside there, hey, you are going to be able to execute that command, and you are going to attack your database. So we talked about, I mentioned a little bit earlier that these generally work off of REST or JSON plus REST. And so what can you do with REST? How does REST work? Well, REST actually maps really well to CRUD, so create, read, update, delete. REST maps really well to CRUD in terms of document access, which is what database really is. So if I want to create a new document, it's generally done with an HTTP post. And this is all real couch syntax. So I want to post to my DB/docID, and then a little bit of JSON to represent the doc. So that's create. If I want to retrieve, it's just a get. If I want to update, it's a put. And then create and update are often like synonyms. Like I can use put to create, and I can use post to update almost every single time. So there's not a lot of reason to use one over the other. And then delete is just delete. And as an attackers, we'd like to be able to do all of this, right? But we'll start with retrieve, because that's the hot thing to do, is to steal all the data out of somebody's database. That's where all the juicy info is that we can go sell. So how could we do this? the traditional way of performing a get-based CSRF is through these like image source tags. So I'm going to create an image tag, and the source is NoSQL 5984 all DBs. And I will package this up in an email and hope you open it, or I will put it on my own page and lure you to visit it somehow through some kind of social engineering attack. And then when you do that, you'll go make the request. Now, like the normal reason we do this is to write on somebody else's session, right? Like there's some kind of cookie that you have. You're logged into your bank, so I can lure you to say, you know, bank.com/transfer funds, $1,000, target equals Brian. But that's not why we're doing it here. There's no auth. Since there's no auth, there's no session. So there's no session, there's no cookie. We're not trying to ride on anybody's session cookie. We're just trying to tunnel inside the firewall. And it's really easy to make somebody do this. I can send this to you, and you can open it. But for me as an attacker, it did me absolutely no good to make you do that. All I did was make you go read some data that you could read. It didn't come back to me. You just reading it is just you reading it. So until I can get that back to me, it's pointless. So this attack is not a good attack, unless JSON-P is involved. So JSON-P, we talked about it being JSON over REST. A lot of NoSQL also, it's usually not by default, but you can optionally turn on JSON-P. So JSON-P is JSON with padding that lets you wrap the returned JSON object in a callback. So you basically say, all right, so instead of saying NoSQL 5984 all DBs, give that back to me as JSON, you say NoSQL 5984 all DBs, and a callback is foo, or steal your data. And what will come back from the server is not just the raw JSON, but it'll be wrapped in a method called foo, or steal your data, or whatever it is that you specify. So all I have to do is hijack this, is make my own little script here with the own defined callback. So if I make this on a page and lure you to this page, the script is going to automatically fire. The bottom one will fire. The server will return the JSON script wrapped in steal your data, which will then execute because we just defined what steal your data is ourselves. And in there, I can do whatever I want with it, send it back to myself, et cetera. There's really no good reason to use JSON-P, period. Like, the whole thing exists as a hack to get around the same origin policy. If you really want to get around the same origin policy, there's much more secure ways of doing that, cross-origin resource sharing, the new HTML5 stuff, you know, cross domains, things like that. So this is a horrible hack. It leads you open to JSON-P hijacking. I recommend that you totally turn it off anytime you've got any data that you don't want the entire world to be able to read. All right, so let's assume that you've done this. What other ways can we do request forgery attacks? Well, we've got RIA-based, get-based CSRFs. So I'm going to use AJAX in this case. I'm going to new up a new XML HTTP request. I'm going to have it call the get to NoSQL 5984 and send that. And then when that's done, the callback I specify will fire, and I'll read that data, and I'll send it back to myself. And I can use this not just for gets. I can use this for puts and posts and deletes and everything. Problem with this is the same origin policy won't usually allow this, unless they're what I was talking about before, you've set up some kind of special cross-origin thing, which is why you've really got to lock that down as tight as possible if you are using it. It's still better than JSON-P. So again, and you are unlikely to have set up some kind of cross-origin resource sharing thing on your database server. So while if you have, it would be the end of the game. Again, it's unlikely that you're going to have it done. So are we done yet? Not quite. There's one more, and this one is going to do it for us. Post-based CSRF, which a lot of people didn't think was possible for a long time. But now we know it is. What can you do with it? Well, here's another page I just created. So I'm going to have a form on this page with the method as post, and the action is the resource I want to attack. I just put the data in the name field, and I use a little bit of script to auto-submit this form. So when you come to this page, your browser is going to make an automatic silent post to NoSQL 5984 DB with the data that I specified. And this is fine by the same origin policy. Same origin policy has no problem with this at all. You can make cross-domain posts all day long. What does post do? Remember, we got into this. We wanted to do a get. We wanted to retrieve the data. Well, this is not a retrieval of data. This is just a post. So a post is creation of data. OK, so maybe that's not quite what we wanted, but that's going to get us everything we wanted. Let's take a look. So I'm going to go back. I'm actually going to go up to my server. And I've got a little page here. So this is the social engineering page. Click me, click me, click me. So I'll go through each of these. And theoretically, I would do a much better social engineering job, but I'll let myself be lured into this right now. So I'm going to click the first click me. Oh, you know what? I forgot something really important. So this is the music database that I was talking about before, just listing out the all the particular albums in there. Now I've got to wait because it's slow. All right, so it was just the first three. So I had in there Black Keys, Pixies, and Death Cab, and what I added in was the Beebs here as is just a fourth item to execute into that I just added to the database. Okay, that's kind of an interesting nuisance attack. Like if it was some kind of like catalog, maybe I could add new items, but not a world-shattering thing in the long run. But what about this? What's kind of the new hotness in terms of injection attacks? It's not just you use SQL injection or NoSQL injection or whatever in order to extract out data, although it still is a very lucrative kind of attack. Now, the new hotness is to actually inject in data into the database in the form of script. So the Liza Moon attack is like this. The Asprox attack of a couple years ago is like this. So what the attackers would do is actually inject in JavaScript into the vulnerable database on the premise that the way the app worked was that it pulled data from the database to render on the page when the users came to visit. And this infected like millions of sites. And the script sites just pointed to malware. And that's exactly what happened. A user would come to the site. The app would pull data from the database, render it on the page, and it was vulnerable script. And we all say, OK, validate user input. Great. But no one ever thinks to validate data that comes out of their own database. Like, generally, people think of that, well, it's just my data. It came out of my database. It's trusted. Well, in this case, it wasn't trusted. It was actually injected in. So if we come back here to I should have been doing this all along. If we come back here and refresh the page and see what actually happened, this attack actually injected a little bit of script onto the page that's now going to execute when so it's a combination NoSQL injection / persistent cross-site scripting attack. Now one more. Should come up in a second. There we go. Remember one of the things we wanted to do? We wanted to be able to call all those various verbs. We wanted to be able to call get and post and put and delete, but we never found a good way to do it because the same origin policy stopped us. We couldn't use that XHR object because it was on a different domain. Well, now we're not. If I can lure you, someone inside the firewall, someone who's maybe on the exact same machine, if it's a small company and you're doing dev work on your server or whatever intranet server that I happen to understand, if I can get you to insert an object into your database and execute that in terms of script, well, now the same origin policy is out of play because I'm on that machine. And now I can do whatever XHR attacks I want to do. And this is what I've done. I've actually pulled out all the data from the database via a get. And I just alerted it up, but I could just as easily have sent it to myself. So because I have post, I can execute arbitrary script. In this case, it's still just the client. I can execute arbitrary script on someone who has authority to run that, and boom, get the entire contents of the database back out. So post is really everything that we need. We didn't need all the rest. That's just kind of frosting. So again, yeah, that's all we need. Now again, a lot of you are probably saying, hey, what does this have to do with JavaScript injection, Brian? You're showing us more NoSQL injection attacks. Answer is MapReduce, and I kind of alluded to this at the beginning too. So MapReduce, if you're unfamiliar with it, is really, really popular and only growing in popularity. It's a way to parallelize really big processing of tasks. So this is what you use the cloud these days, not just for serving many people, but if you've got one really, really big job and you want to parallelize that across many machines, well, MapReduce is a natural solution for that. The canonical example of MapReduce is, hey, we have a book and we want a word count for each of the individual words within that word. So how many times does the word the appear? How many times does the word browser appear? Whatever. And if you were to go through that straight in a single process, it could take you a while. But a better way to do that is to parallelize it across as many machines as you have or you have access to. So you basically break it up and say, all right, well, this node or this machine, you take this chapter, you take this chapter, you take this chapter, you take this chapter, and they each do their individual processing, and it comes back to a central reduce function, and it combines all the results. So chapter 1 had 80 those, and chapter 2 had 20 those, so now we've got 100 those. So basic parallelization of this. OK, in NoSQL, you do that MapReduce with JavaScript. So here's Couch. You can actually do, again, because you have no common schema, if you want parallelized filtering, you do that through JavaScript-based MapReduce functions. You can actually even create temporary ones. I'm running out of time. I'm not going to show a demo. Basically, what you can do is now that I've added arbitrary documents to the database. Above and beyond just adding documents, I can also add views. Those views are JavaScript MapReduce that execute on the server. So I can now inject into you arbitrary JavaScript to execute on the server, and all the other stuff that I talked about comes back into play in terms of exploits. OK, so again, I'm getting low on time, but it's always good to talk about some mitigations. I hate to be the guy who stands up here and talks about problems, and no solutions. This is unfortunately going to be a much heavier attack than solution talk, but we can cover the mitigations pretty easily. Here's the first one: is validate user input. Never trust the user. I mean, this is a mantra we should all be saying in our sleep by now. Validate, validate, validate. We've talked for years and years about the importance of testing user input, and this just goes to show it more. Specific cases here, if you've got like the MongoDB and PHP thing, if you're expecting a string and you're getting an array back, that should probably be your first clue that somebody's attacking you. So test your type, use your regular expressions. All the stuff we've been talking about for years still applies and is going to save you here. Don't use eval. Don't use it on the client. Don't use it on the server. If you're processing JSON, which is really the most common use of eval that I still see these days, there's much better ways to do JSON parsing, like JSON.parse is a much safer alternative than eval. Eval's got some evil cousins too. Set timeout and set interval are actually functionally equivalent to eval, so keep an eye out for those too. You see set timeout quite a bit in terms of Node code. Speaking of Node, Node's also got one of the cool things on that list of all the things that Node can do. It's got one called VM. And this is actually a sandboxing mechanism. So what this does is it prevents you from pulling in all the other little modules. So I showed, hey, we're going to pull in the FS module. We're going to pull in the child process module. If you run your code in this VM sandbox, it prevents you from doing that. But anything that you've manually pulled, so you basically say, all right, here's the VM, and I want to have access to A, B, and C. Well, the injected code, it's not perfect. The injected code is still going to have access to A, B, and C. It's just not going to be able to break out of that so much. So it's a way to reduce the attack surface of your running code, which is a good thing, if not a perfect defense. I call this a good defense in depth mechanism. I did talk about this. Use your particular language database drivers for NoSQL. Don't try to do ad hoc NoSQL. And then implement some auth in the database you're using. I shouldn't even have to say this, but the fact that it's not there kind of goes to show that, yes, you do need to roll your own. It doesn't need to be completely extraordinary, but it does need to be something there than just having you wide open to request forgery attacks. All right, so I've saved a little bit of time for questions. If there's nothing I got to and you can't get to me, this is my blog, is blogs.adobe.com/asset, and my email address is brsuliv@adobe.com. So if you don't get to me today and you want to send me an email, please, by all means. And other than that, in the little bit of time left, I'll be happy to take any questions that you have. Which appears that there are none. So thank you very much.